Our topic for today is Introduction to Differential Equations. So, differential equations are equations that contain differential coefficients. Like say for example, dy over dx is equals to 12x, or dx over dt plus 3 is equals to 4. Now, differential equations also classified according to their highest derivatives that occurs in them. So the differential equations, let's say for example, dy, dx is equals to 12. Now, this is in the first order differential equation. This is the first order differential equation. And then the other example is the d squared y is equals to the dx squared plus 4 dy over dx minus 3 is equals to 0. So this is in the form of second order differential equation. Now, a solution to a differential equations contains one or more arbitrary constants of integration. So this is called the general solution. So when an additional information is given to these constants, may be calculated as a particular solution of the differential equation. So that's the additional information is called boundary conditions or initial conditions. So for example, let's work with the formula from physics. Force is equals to mass times acceleration. Now we know that acceleration is equals to, so we know that acceleration is equals to the second derivative of the position over time. So dx squared over dt squared. So formulating the equation that we know, force is equals to mass times acceleration. We know that acceleration is equals to force over mass, and then this becomes dx squared over dt squared is equals to force over mass. Now this is the derivatives, and this is some constants or junk constants. So we'll tackle this specific equation for us to know, because this equation is easy to comprehend. So now let's say for example, F over m, or the force over mass, is equals to 30. So dx squared d squared x is equals to the dt squared is equals to 30. Now integrating that sides in terms of t, so integrating this dt, we should know that dx over dt is equals to 30t plus c. Now we have arrived at the our first derivative equation. So we have not yet solved for the value of x in terms of t. So let's try to integrate the equation. Dx over dt is equals to the integral of 30t plus c. The equation becomes x function of t is equals to 30 over 2 t squared plus c1 t, this is c1, so that's your first derivative constants, so plus c2, your second derivative constants. So we have two constants because our derivative is in the second order differential equation. So now we have these two constants. So simplifying the equation that we get, x of t is equals to 15t squared plus c1t plus c2. This is now your general solution. So if we have some initial conditions that are given in the problem, now we can solve for a particular solution or a specific solution. So general solutions, it describes an infinite or all the possible solutions. So the reason is you have the reason that we have two constants because we have in the second order differential equation. So another example is we have the when t is equals to 0, now the x is equals to 0, and then x prime is equals to 1. So our example is dx over d squared x over dt squared is equals to 30. So let's try to stick the in that equation. So we know that our general solution is x is equals to 15t squared plus c1t plus c2. So you know that when when t is equals to 0, x is equals to 0. So 0 is equals to 15 times 0 squared plus c1 times 0 plus c2. So we have arrived that c2 is equals to 0. And then the x prime or the dy dx is equals to 1 when time is equals to 0. So substituting the first derivative that we get, so rewriting that, so dx over dt is equals to 30t plus c1. So 30t plus c1. So dx over dt is equals to 1 is equals to 30 times 0 plus c1. Now c1 becomes 1. So substituting all the constants that we got in the general solution, so x of t or function of t is equals to 15t squared plus c1 plus c2. But we know that c1 is equals to 1 and c2 is equals to 0. So the final specific solution for this initial condition, x of t is equals to 15t squared plus t. So you know that this c1 is 1 and this is 0. So your specific solution is 15, x is equals to 15t squared plus t. So another example is, let's try to solve for the general solution and the specific solution for the equation d squared x over dt squared is equals to 3t plus 1. So how do we solve that? We try to integrate both sides in terms of dt. So d squared x dt squared dt is equals to the integral of 3t plus 1 dt. Now we should get dx over dt is equals to 3 halves. The integral of 3t is 3 halves t squared plus the integral of a constant 1 is t plus the c1. So don't forget the constant. After we have integrated the equation, now this is your first derivative. So deriv is the derivative. So we try to solve the x in terms of t. So integrating again the equation dx over dt times dt is equals to the integral of 3 halves t squared plus t plus c1 dt. So integrating the equation becomes x function of t is equals to the integral of 3 halves t squared is equals to 1/2 t cubed, and then the integral of t is equals to 1/2 t squared plus integral of constant c1t plus c2. Now this is now your general solution. This is now your general solution. So after that, we try to solve for a specific solution that given the initial conditions for the following is when x of 0 is equals to 2 and then x prime of 0 is equals to 3. So you know that when time is equals to 0, x is equals to 2. And then when time is equals to 0, the dy over dx is equals to 3. So we try to solve for the value of constant 2 or the c2. So substituting the initial conditions that are given, so x of t is equals to 2 and then 1/2 times 0 to the cube plus 1/2 times 0 squared plus c1 times 0 plus c2, and then c2 becomes 2 is 0 0 0, so c2 now becomes 2. And then substituting the dy dx or the first derivative when time is equals to 0, dy dx is equals to 3. So our dy dx, the dx over the dt is equals to 3/2 t squared plus t plus c1. So substituting the values, so when time is equals to 0, dx over dt is equals to 3. So this now becomes 3, and then 3/2 times 0 squared plus 0 plus c1. Now c1 becomes 3. So you have all the constants, and then we can now solve for the specific solution. So substituting all the constants into the general solution, so x is equals to 1/2 t cubed plus 1/2 t squared plus 3t plus 2. So x is equals to, so this is now your specific, this is now your specific solution. So that's it. That's your introduction for the differential equations. Hope that you have learned, and then thank you.